Hi there and welcome to today's class. For today's class, we're looking at something called the coefficient of restitution. Now, in our previous class, we talked about the concept of collision, where we say for collision, two bodies forcefully hit against themselves. And we said basically we have two types of collision. We have the elastic collision and the inelastic collision. Now, let's look at the concept called coefficient of restitution. By definition, coefficient of restitution is the ratio of the coefficient of the relative speed or relative velocity after and before an impact taken along the line of impact. So simply, coefficient of restitution is simply the ratio of the relative velocity of two bodies after an impact to the relative velocity of two bodies before an impact. All right. Now, coefficient of restitution is abbreviated by the symbol E. All right. So we use E to represent coefficient of restitution. So let me give you a diagram to explain this. So let's say, let me use an elastic collision. For elastic collision, we said we have two bodies. Let's call this bodies A or body 1. We call this body 1. Call this one here body 2. All right, so this is before collision. So I have this before collision. So before collision, body A is coming this way here with its initial velocity u1. Body B is coming this way here with its own initial velocity. Let's call this u2. Now this is before collision. After collision, let's say they move in separate or opposite directions. So after collision, I now have that body B this way moves in the opposite direction. So the initial was u2. Let's call the final here v2. That's the final velocity of body 2 after collision. And for body 1, I have this. Let me call this 1. Body 1 is going this way. So let me call this v1. All right. So let's say I have this. So let's say I have two bodies here before collision and after collision, such that their initial velocities is given by u1 and v1, and their final velocity is given by v1 and v2. Now, in this case, we were saying that the coefficient of restitution E is equal to the ratio of the their relative velocities before collision to their relative velocity after collision. So for this now, the formula becomes here. Okay, so we're saying that for this here, the coefficient of restitution is equal to the ratio of the relative velocities after collision to the relative velocity before collision. All right. So here it becomes relative velocities after collision divided by, since we say ratio, we're using the division, divided by the relative velocity before collision. All right. So this is my mathematical expression of coefficient of restitution. This will be equal to, so E will be equal to after collision is V1 and V2, so it becomes V1 minus V2 all over, of course, U1 minus U2, that's before collision, becomes U1 minus U2. So I have this. Now, for this one here, if I do this way, probably my answer can give me negative. Now, I don't want a negative value, all right? This value is always positive. So to make this positive, I will just take the absolute value. So I have this. All right, so in a mathematical form, we're saying that coefficient of restitution is equal to the absolute value of the ratio of the relative velocity after collision to the relative velocity before collision. So we have this as a mathematical expression. Now the question is this: why are we even talking about coefficient of restitution? All right, what's the function of coefficient of restitution? What do we use the idea of coefficient of restitution for? And the answer is very simple. The coefficient of restitution only helps us to, it helps us to identify the type of collision, the type of collision we have. All right. So the function of the coefficient of restitution is to identify the type of collision that is taking place in any scenario, in any problem. All right. So basically, we talked about two types of collision. We talked about the elastic collision and the inelastic collision. But aside this, there are also other types of collision, which includes perfectly elastic collision. It exists. There is perfectly inelastic collision, and there is super elastic collision. All right. We'll look at these ones then. But before then, how does this help us to know which of them is a perfectly elastic collision, which of them is a perfectly inelastic? How does this help us to determine the type of collision? Now, very simple. Here's what to note. So note this, please. Note this. Note the following. This is how coefficient of restitution helps us to know the kind of collision. Number one, note that if the coefficient of restitution is equal to 1, then the collision is perfectly elastic. Is perfectly elastic. So I have this. All right, that's the first one. Number two, if the coefficient of restitution is between 0 and 1, that means if E is greater than 0 but less than 1, then the collision is inelastic. All right. Number three, if the if the coefficient of restitution is equal to 0, then the collision is perfectly inelastic. Is perfectly inelastic. Then finally, number four, right? Number four, what if the coefficient of restitution is greater than 1? What happens? Then the collision is a super elastic collision. All right, so these are the these are like the 4 conditions when it comes to using the concept of coefficient of elasticity. All right, if the value is equal to 1, then the collision is perfectly elastic. By perfectly elastic, we mean the body after collision move in their separate ways. All right, with different velocities. Number 2, if the coefficient of restitution is between the value of is greater than 0 but less than 1. All right, if E is greater than 0 and less than 1, then the collision is inelastic. All right, number 3, if the coefficient of restitution is equal to 0, then the collision is perfectly inelastic. For a perfectly inelastic, it goes with the same concept of inelastic collision, where the two bodies combine and move with the same velocity. Now, finally, number 4, if the coefficient of restitution is greater than 1, then, then the collision is a super elastic collision. All right. Now, the question is this: what is a super elastic collision? A super elastic collision is a collision in which the potential energy is converted into kinetic energy so that the total kinetic energy of the colliding objects after collision is greater than the kinetic energy before collision. All right, that's a super elastic collision. So for a superelastic collision, you're saying that the kinetic energy is a kind of collision where potential energy is converted into kinetic energy, so that the kinetic energy, that's Ke, after collision, let's call it A, is greater than the kinetic energy before collision. Let's call this B, right? So for a superelastic collision, we are saying that kinetic energy after collision is greater than kinetic energy before collision. So this kind of collision, although it happens in rare cases, it's called a superelastic collision. All right, so let's take a problem on collision, and then we see how we can use the concept of coefficient of restitution to determine what kind of collision is happening there. All right, let's try this example. This one says a 4-kilogram ball moving with 8 meters per second collides with a stationary ball of mass 12 kilogram, and they stick together, full stop. What is the final velocity and the kinetic energy lost in the impact? Also, using the coefficient of restitution, state what type of collision occurred. All right, let's get this done, please. Solution to this. So first things first, as usual, is to list out my given parameter there. The first thing I'm giving there is that we have a 4-kilogram ball. So I could call that the first one. Let me call this mass 1 or mass A. M1 is equal to 4 kilogram. Next up, they said moving with 8 meters per second. Okay, that means U1, the initial velocity of this one here is 8 meters per second. Number 3, proceeding, they said collides with a stationary ball of mass 12 kilogram. So I'm giving a second mass, M2, as equal to 12 kilogram. Next up, they said, and they stick together, full stop. What is the final velocity? Now, first things first, they said this ball here is stationary. So if it is stationary, what does it mean? If it's stationary, it means it is not moving. Hence, its initial velocity is equal to 0. So you should be able to decode that from the question, all right? A stationary ball, it means that its initial velocity is equal to 0. So we can say that number 4, U2, that's initial velocity of this one here, is equal to 0, right? So please note this. All right, they said, what is the final velocity and the kinetic energy? Okay, so let me bring this here. Number 4, U2 is equal to 0. Okay, take this off. All right, said, what's the final velocity and kinetic energy loss in the impacts? We know that for this case here, since they say they stick together and move, what comes to mind? It's now the inelastic collision, right? Since they come together and they move, so probably it's surely an inelastic collision from our last class. Okay, so if you missed out our last class on inelastic collision or on collision, I'll leave a link in the description of this video. All right, so check the description of this video. You see a link to watch our previous class on collision. All right, let's proceed with this. So I have U2 as equal to 0. We asked to find the final velocity. Of course, there will be just one final velocity, that's V. Number 5, we'll have just V equal to 0. So since they move, that's both the 4-kilogram ball and the 12-kilogram ball move with one velocity, we'll have just one final velocity, as we discussed in our previous class. All right, for this, we have to find the value of V. How do we find this? For this now, we'll have to recall the formula for this. And what's the formula? Recall this. So recall that since they stick together, it's now an inelastic collision. And recall that we said for inelastic collision that the formula is M1U1 plus M2U2 is equal to M1 plus M2V, right? So this was the formula for inelastic collision. So let's get this done. Put in values. M1 is 4, so I have 4 into U1. U1 is 8 plus M2. M2 is 12 into U2. U2 is 0 is equal to M1 plus M2. M1 is 4 plus M2 is 12 into V. I have this. All right, so I just simply brought in the values here. All right, so 4 times 8 there, I have 32. This is 32 plus 12 times 0 is 0 is equal to this time, this plus this is what there? 16, right? 4 plus 12 is 16 times V becomes 16V. From here, we'll have that 32 is equal to 16V. Let's find the value of V. I'll divide here by 16, divide here by 16. So V is equal to 32 over 16 gives you 2. V is speed or velocity measured in meter per second. So the value of V is equal to 2 meters per second. Now going back to my question. We've gotten the value of, they said find the final velocity, we've gotten the value of V, and they said find the energy, the kinetic energy lost in the impact. How do we find kinetic energy lost in the impact? All right, so how do we find kinetic energy lost in the impact? The idea will be very simple. First things first, I'll look for kinetic energy before impact all right, and to get that, I'll simply use this formula here, but in terms of kinetic energy. All right, we said this in our previous class also on collision. Again, if you missed our previous class on collision, just check the description of this video. I'll leave a link to the class there. All right, we said the kinetic energy before collision, before impact, all right, or before collision is this one here. We give a formula as half M1 U1 squared plus half M2 U2 squared. This was the formula we gave. And if I write this down, this is equal to half into M1. M1 is 4 in value into U1 squared. U1 is 8 all squared plus half into M2. M2 is about 12 kilogram into U2. U2 is 0, so you can see here, becomes 0 squared. So I have 0 all squared. All right, so this is equal to half into M1, that's 4, into 8 squared is 64. So I'm having 64 plus half into 12 into 0 squared is 0. So put in values, this becomes half times 4 is 2. 2 times 64 should give you about 128. So 128 plus, so half times 12 is 6 times 0 is 0. So before collision, I have 128 joules as the kinetic energy before impact. Let me call this KE1 as kinetic energy before impact. All right, let's get kinetic energy after impact. Let's get kinetic energy after impact. So what would this give me? My formula 2 would take this form here. We discussed this also in our last class. We said the formula will be half into M1 plus M2 into V squared. We would have this. All right, impute values. This is equal to half into M1 is 4 kilogram. Okay, plus M2 is 12 kilogram into V squared. V V is 0, so into 0 squared. All right, so that will be equal to, if I work on this, that will give me half into 4 plus 12 is 16. 16 into 0 squared gives you 0. Multiply all of this. Half times 16 is 8 times 0. We have 0 as your answer. So let me call this KE2. KE2. That's kinetic energy after impact is 0. So the question here was to, let me use the exact terms. The exact terms here was to find the loss of kinetic energy. All right. So therefore, the loss in kinetic energy, let me use KE, will be equal to kinetic energy before impact minus kinetic energy after impact. All right. So have kinetic energy before impact into V squared. V is 2. That becomes 2 squared. And that's equal to half into 4 plus 12 is 16 into 2 squared is 4. All right. If I get this done, this will be equal to 32 in value, 32 joules. So half of 16 is 8 times 4, that's 32. All right, if this is true, that means we have to find the loss in kinetic energy. So we can say loss in kinetic energy is equal to, it will be, so let's call this one, let's call this KE2. I'm calling this KE2, that's kinetic energy after collision. The loss in kinetic energy will be equal to the change in kinetic energy, and that's equal to the kinetic energy before impact minus the kinetic energy after impact. And that's equal to, before impact, we have 128 joules minus, after impact, we have 32 joules. So if I do the maths there, 128 minus 32, that gives me about 96 joules. So I have this. So therefore, we can say that the loss in kinetic energy is about 96 joules. All right, the final task here, final question here says, also, using the coefficient of restitution, state what type of collision occurred. So from here, we already have an idea that what occurs here should be an inelastic collision. But then let's use the concept of coefficient of restitution to determine the type of collision. All right, so from here, using the concept of coefficient of restitution, we said E is equal to, my formula is absolute value of V1 minus V2 all over U1 minus U2, of course, absolute value. So this is equal to, I'm having absolute value of V1. V1 is, okay, there's, of course, since they move with the same velocity like this, that means V is equal to V1 and is equal to V2. All right, that's yep. So V is unknown, of course, but we got V as 2. Yep, we got V as 2. That was this value here, V as 2. All right, so we had V as 2. All right, so that means V1 is equal to V2. They're the same value. So V1 is 2 minus V2 is also 2, all right, all over U1. U1 is 8 minus U2. U2 is 0. So I have this. So this is equal to 2 minus 2 is 0 all over 8 minus 0 is 8. If I work on this, it means that E is equal to 0 over 8 gives you absolute value of 0, and that's equal to 0. What absolute value does is that it gives you your number, your value as a positive. So let's say I had E of, so that means if I take absolute value of, let's say 2, the answer will be equal to what there? 2. If I take absolute value of minus 2, the answer will be equal to what there? 2. So the concept of taking absolute value is so that I'll have what there? A positive answer. That's all. So if I take the absolute value of a positive number, it gives me that positive number. If I take the absolute value of a negative number, it gives me the positive form of that. That's just all. That's all that absolute value does. So this is true. Now what do I have here? From here, I'll now have something that looks like, so since E is equal to 0, you can say therefore, since the coefficient of restitution is equal to 0, then the collision is perfectly inelastic. That was the condition. We said if it's equal to 0, it is perfectly inelastic. So therefore, in this case here, it is perfectly inelastic. So this is how we solve this question. All right, so to get more of my classes, all right, simply visit my website www.jonaemmanuel.com/courses. Then you see the WAEC/JAMB classes. Then you have access to over 50 of my classes on physics, mathematics, chemistry, and the other sciences. All right, so just head on to www.jonaemmanuel.com/courses, and then you can get more of my courses there. All right, see you in our next class.